Hello everyone, and today we are going to be solving a problem with 3D printing. So, what is the problem? Well, I had a really good find at Goodwill about 2 months ago, I think now. It's been a while. And I've just been having a hard time finding hardware to make this possible, or a solution in general at first. But basically, I found a audio interface kit by PreSonus. It's a bit older, so the hardware is a bit old. However, from what I can tell, most of it is functional. All of it is functional at least 90% of the 80% of the time, somewhere around there. It came with an audio interface, which is what I'm actually using to put my microphone into now, because it's better than the mixer board that I was using as an audio interface, which is why there was so much noise before. And then, unfortunately, this audio interface sometimes has issues with noise anomalies where it makes pops, clicks, and other digital sounds. But then also the kit came with a blue XLR cable and this microphone with this little stand. I'm trying to make it as easy as possible to see. This little stand attached to it. And then the kit was also supposed to come with headphones, but I got it at Goodwill for $10, and all of this seems to work, so I'm not complaining. I do kind of wish I had the headphones, because trying to find a good set of more affordable headphones is really hard. They are always overdue the base nowadays. Anyway, so the problem lies with this little stand thing here. So this is a condenser microphone, for those who don't know. And that means that it needs to be powered, and it usually gets held like so. This is not normal the way that I'm doing this, but this is how this microphone is designed. So, what the heck? So, for those who are in the know about microphones, I normally use an Audio-Technica AT2020 condenser microphone, which also came with its own stand or microphone mount. And how that microphone mount works is that it screws on to these threads, and it has a ring. I think it has like a threaded ring inside of another ring, so that you can turn the microphone whatever way you want, and then you spin the like internal ring, so then it actually tightens the threads, and then it clamps down into the position that you have held it or presented it once you've tightened it. This one does not work like that. This one has no threads on the stand. So it just cups the, even though for some reason the threads are kind of tight on this, but it just kind of cups the microphone, and then this like makeshift proprietary nut is, it clamps down and holds onto this. So my original thought was that I needed to make the entire assembly for the microphone mount, and eventually, I came to the conclusion that that was stupid, especially once I tried to find what threads these were, which was a severe challenge. I eventually got an answer from PreSonus support, but yeah, I won't be needing that, luckily, and it would be much more difficult to find threads for this, because these threads are proprietary and very fine, and the finer the thread, the more difficult it gets to try and find hardware, which leads us to our next issue. So what we need to replicate is essentially this, except this part is taken care of, this top part. So what we need to make is this, wow, this thing is tight. What we need to make is this bottom piece. This bottom piece. And this is the part that has the threads that go onto a microphone stand. I have one back there. It's not angled well to be seen. I only have a back there to be referenced if I needed it to be. So what I wanted to get these threads, because they are the most universal, because oftentimes microphones come standard with 2 different size threads. One of them is the small threads, which are on this one. But there's the small threads, which then get adapted to these big threads. But since a lot of the microphone stands now come with those small threads, I had to just deal with it, because unfortunately, finding something to go around these big threads in a nut, which is what I needed to have hardware in my 3D print, finding that in a nut is hard. What was actually much easier was finding a nut to go on the inner diameter. So that's what I have here. So these are the same size. It's just that this is a regular nut, so it doesn't have an adapter, but this will work for accomplishing my goal of making a functional microphone mount so that this can actually go on a stand. That's why this is a problem, is because I only have half of the microphone mount, and there's no way to mount this unless I like set it somewhere. But the cord goes in here, for those who don't know. So you have to set it like on your side or hang it off of things, and that's not how you want to do it. Can do it that way, it's just not how you want to, especially if this is a lighter, cheaper microphone. But it just I'd prefer not to. And it gives me an excuse to make this video. So yeah, this takes care of the bottom thread problem. The next part is finding the swivel mechanism for this. Now, I could implement the swivel mechanism into the design. I could do a snap-in design like I was trying to do for my radius gauge box set, which I unfortunately am not going to be uploading a video about making because it just took so long and there's too much footage. I don't know how to actually condense it down into something watchable that anyone will actually watch. But you can see it sort of work in my TPU video, which is also sort of long, and people, I got criticized for having it be so long. But, I don't know, everything I included I thought was important. Anyway, basic idea is that this is going to be the same thing as this. I did not know the exact width that I would need, because this is also a little bit wider, which is why I couldn't like cannibalize one of these stands, or I think I might have been able to if I really wanted to, but I wanted to make a whole new one because I didn't want to cannibalize one of these. And it's also, I couldn't find, I used the wrong keywords, but I couldn't find a replacement one of these types of mounts. If I had used the right keywords, I might have been able to find it, but once again, I'm going to do things my way. This is a bolt and a wing nut. So the bolt goes in through and it just goes through the thing off. Okay, now. It goes through here, which then it will also go through the holes of the stand, the actual mount, and then the wing nut will tighten down to hopefully be able to lock in the angle. I'm really hoping that will work. I don't know if it will, but I'm really hoping it will. Especially that I'm hoping that it won't have to have so much pressure to hold it that it will snap the plastic, which it might, because the way that I'm thinking, I might have to print this in this orientation, which can be bad for print strength. It's all stuff that I'm going to have to experiment with, but I'm hoping that this will be somewhat straightforward of a design. Now I've been talking for 10 minutes. Let's get into the designing so that I don't waste too awful much more time. So yeah, I have all of my stuff here that I should need to complete this model, because I have everything that should need to be referenced right around me. I have the microphone stand, I have my hardware, I have other referenceable hardware, and all of the good stuff. The only thing I don't know for sure of is where my calipers are. Oh Christ, and my living space, oh here they are. The living space is in kind of chaos right now because I'm very overwhelmed with a lot of different things. My desk is unfortunately one of the things. Turn off, you son of a gun. I don't want to waste the battery. My on-off button just not work now? Now it's working. Cool. Gotta get some better calipers, but they're just kind of expensive to get decent calipers. But, you know, when you want a precise measurement tool, you should probably spend a little more. Oh, alright. Now, this is a good question of where I should put this. I'm going to put it under audio hardware. I'm going to make a new project called audio hardware, because I have some other plans for a few other things as well that involve audio somewhat, at least. Could have probably put audio hardware under tools, but I don't know. Alright. We need a new project, which they already open it and then you save it. It's kind of, I won't say it's unintuitive, but it's a bit of a strange way to handle situation. Now I need to decide how I'm going to start this. I think we need to start with let's start with how the base is going to look. So we need to accommodate this going inside the print. First thing we need is a sketch on the top plane like we are looking at right now. Then we need to make a hexagon in this size. So it's got 14 millimeters of outer width. Is there an easy hexagon tool? Doesn't the circle tool have some like interesting... I looked up how to do this. Polygon. I think it's this one. Then we'll just use the center point. Needs to be 14 millimeters, and then it needs to have 6 sides, yes. Can I get an angle, please? That'd be really cool. Need the horizontal. There we go. Okay, it locks it. So now we have, this is the outer diameter of this. So one crucial error made here right off the bat is that this is actually not the diameter. This is the radius measurement. So instead of 14 millimeters being the whole width of the X shape we've made here, the hexagon, it is half. So now it has 28 millimeters of diameter instead of 14. I'll realize this later after we've already printed the first version of this, but that is, that's just the way it is, and I don't want this to be looming over the video for the whole thing. So to make it fit, we need it to be a little bit bigger. Now, I'm going to be printing this on my Bambu Labs P1P, and it has pretty good tolerances. Usually 0.2 millimeters is a good fit tolerance. However, I want this to be a snug fit. It would also be nice if I could remove it somehow, but I don't know. I'm going to do it at 0.1 for now. Let's actually make some parameters here first. So this is going to be stand mount red nut. Okay. And then it will be 14 millimeters. Then we'll make another parameter called snug fit. And for those who don't know, you can't use spaces in these, so I just use camel case to do stuff. We're going to do 0.1 millimeters, go back into here, into the expression, and just simply do plus snug fit. Doesn't it? What? Oh, that must be the name. This is the expression. It's been a little while since I've used CAD. Give me a break for a second. Plus snug fit tolerance. Okay. And then we need to remove this millimeters on the end, otherwise it breaks and doesn't like it. And then we also need to change this value to that. It'll be the same value, but it will now be able to be changed within that parameter. Now we need a proper thickness on the outside, and I'm thinking that I just want to make the whole thing a hexagon shape, that it has a grip that you can hopefully twist it off properly as well. Now what's a good thickness to go around it? It's probably going to need to be pretty thick anyway to be able to support the parts going around here. See how thick this is in the first place. It's actually 8 millimeters. So we have, okay, interesting. Let's start with 6 millimeters of, what's it called? Of offset. First thing is make a parameter for it. Body, start with 6 millimeters. Okay, so we're in a sketch. I think we can use, yeah, there it is, modify. So then we have that thickness. Now this is the total size. Right. Just thinking. What I was originally thinking is that I'm gonna need to have like a lid on here. What I would ideally like to be able to do is to have a way to be able to remove these threads if something horrendous were to happen, like I cross-thread it somehow. I don't think that I will do that, but I don't want it to be out of the question to be able to salvage it. Unfortunately, that might be stupid of me to think that I can do that. Let's start with this shape. So we need another parameter. It needs to be thickness, or the height of this nut. It's kind of hard to get an actual thickness. It says 8.3, 8.2 roughly. I'm going to go with 8.3. Should I give it an extra millimeter? Don't think it would hurt too awful much. How much is a millimeter? It's not a lot. That's enough to make play in the thing. I'm just going to do it exact size. 8.3. It's 3D printing. Logically, prototyping shouldn't be too expensive. For me, anything is expensive right now, though, because I don't make money. So this needs to be band mount height. I hate having names that long, but it needs to be descriptive to be able to know what the hell it is. And what was it? It was 8.3, I think. Could double check. Yeah, 8.3. So this gets selected, and then we extrude it by that amount. There, that one. So there's this. We accept. Just thinking. So now we can take this sketch. Can I extrude this? Okay. The first thing I need to figure out is the depth of the thingy there. So the screw, the mounting screw may not necessarily be this length. I did try it before recording, and it was very close. So I think we would only need like 0.2 millimeters of extra depth for that screw, but it will, I need to, let me just rinse real quick here. I'm gonna make the executive decision to not worry about it because it was literally flush. Okay, so that takes care of that issue for the most part. Now the next issue is creating the way to glue this in. So what we need to do is we have the sketch visible. Okay, I already done that. Now we take this and extrude, select all of that. We need to create a parameter actually. Always forget to. We need to make a few parameters actually. And mount thread nut. And mount thread nut. Retainer. And I'm thinking 3 millimeters. This is how I do my estimations, is I just I look at my I try and set my calipers to roughly the distance and just look at it. Alright, I tell you what, I like 3.5 better. So that's what we're gonna do. 3.5 millimeters. But also the 3D printer works in 0.2 layers typically, so we're gonna do 3.6. Because we're designing it for 3D printing. So yeah. Numerals of 5 are more satisfying, but numerals of 0.2 work better for 3D printing when using that layer height. So we have that, and then we want band, thread, nut, tane, nub, size, expression. And this is going to be body offset thickness, and then we're going to divide it by 2. Come on, type rate. Then that should be half the size of the actual body, and hopefully it'll be thick enough that it can print decently, but not so thick that it will be absolutely detrimental to the function of this thing. Let's put it in place and see what happens. Let's go into the sketch actually, and we're going to put some construction lines in here. Need the centers, there you go. That little triangle means that it should be in the center of the line or geometry that you're doing, and then the hotkey for making them construction lines is to click on them and select what you want to turn into a construction line, and then press X. So now we have these construction lines to be able to center those holes properly. Finish the sketch. Now we can extrude both of these by the retainer thickness, except for it's going to try and go the wrong way, so we need to go to the front of this and make it negative, and then it will add, and then the operation will automatically select join, which is exactly, no it's not actually, we want them to be new, we want it to be a new body? Make a new body. Okay, it did. So now let's label these. This is going to be main body, red, retainer. Okay, so now we have that. Now we actually, the best way to do this, I think, would be to go back into the sketch, and we create the circles in the sketch. Obviously, that should have been what I did, but it was silly. So now, retainer, nub size. Let's make all 3 of these. Hoping 3 millimeters will not be too small for these little things to print properly. Now we need to make sure that these get put in the proper spot. There's an airplane going over my goddamn house like there is all the goddamn time. Now this needs to be same measurement as I think the nub, because it needs to be put in the dead center, which the nub measurement should handle, even though it's not a precise name for what we're doing at this moment. It is still a logical measurement, and if we change it, it should change properly with the change, if that makes sense. If we change this value, it should alter everything properly. Okay, so now we have that done, and then let's offset these. Let's make another thing here actually. We're going to name this one regular fit tolerance. It's just going to be called fit tolerance, which will be 0.2, not 2 millimeters. And then we're going to offset these by fit offset. And this is going to be important for a little bit later. Okay, all of the fit tolerances are done now, so now we can finish the sketch. Let's work on one body at a time. Let's start with the more logical one, make the actual pegs first. So now we need to extrude by selecting all of the inner circles here. And I need to decide a nub depth, actually. So where is the nub? This one. Control C. I make a new one. Control V. Nub depth. I need an expression. That's a good question. Depth was 0.8, wasn't it? Or no, it was 8.3. That's what it was. Okay, well, let me just eyeball this again. 4 millimeters is a decent size. 3 might be a little short, but it should be able to get the job done. I'll start with 3 for now. 3 millimeters. Now we can extrude all of these inner circles and make sure that it is the inner circles. Alright, nub depth. Now it builds upwards, makes those. Alright. That will be joining with this, and it won't join the main body because it's already hidden. So when the body's hidden, it won't join it. Otherwise, it would join this whole thing together again, which is not what we want. Now, one thing that might matter, I don't think it will, is I could round these off, but I think they're so small that it's not going to make a difference. So I'm not going to worry about it. It's iffy. It's such a small detail that I really don't think it'll matter. I'm doing it. Let's make another parameter for it. Control C, Control V, nub, rounding. And we'll start with 1 millimeter. I think that might be too much. We'll see. Select all of these top rings, rounding. It might be too much, but it's also so small that it's really hard to tell if it's going to be too much. Either way, we select OK. Let me turn that back. Here's where you get to see this in action if you've never seen it before. So we made a mistake here. We made it 1 millimeter. Let's make it smaller to 0.5, and boom. Now they are changed, and that's why we do that. Otherwise, we'd have to go back and either Control Z and do the whole process over again, or something like that. It just sucks, and this makes it a lot easier. Let's actually save our project. Now let's wait one more step. Now we go back to the main body, and we need to extrude again. But this time we do select the outer rings as well as the inner rings. Okay, so now we need to do this the same depth. And logically, I think the height calibration is one of the strengths of the P1P because of it and its auto leveling capabilities. I'm pretty sure that this shouldn't mess anything up. I shouldn't need any extra tolerance to do this. I think just in case I need to let me do that action again. That's pro tip, is that Fusion allows you to actually go back in your timeline and alter actions. So keep that in mind, but sometimes it also doesn't let you do it depending on other things rely on it and all that sort of stuff. And we're also in the free version, at least I am. You can see that it says for personal use. So some more advanced calculations can be done by the program, but will not be because we are in the free version. It allows you to use like 90% at least of the program. And most of what's available can get many jobs done. Now, I came back in here just to add snug fit tolerance to the depth. That 0.1 millimeters should hopefully be more than enough extra tolerance. And we also have these. We also cut it by the extra normal fit tolerance so that these can slide hopefully smoothly into place. And now we put this in place and you can't really see what's going on. However, if we were to section analysis this, which we can do by inspect, and then we select this face, let's do, I actually didn't get far enough. Oh, it's because it was 0.3 instead of -3. We'll do negative, it needs to be negative, what did I call it? Offset. Negative main body offset. That didn't work. Divided by 2. There we go. So, as you can see, these should fit fairly smoothly into place, and the rounding also helps it just kind of fit into the socket better. It helps quite a bit more than you'd think, though they might not exactly turn out because of how small this detail is. That's my only problem, or that's the only possible problem I'm thinking of with that right now. But they also might be irrelevant. I don't know yet, but that's why 3D printing is so great. Let's also take another step before saving, because saves are kind of annoying. And if you want to get rid of the section analysis, you can just make it visible and not visible by, hiding it under your analysis tab or folder in your project. So we have this retainer, but it still needs to allow, ooh crap, I just thought of something. This is going to add extra depth that this is not going to be able to support. I wonder if there's still going to be enough thread, if this is needed. I wonder if there's going to be enough thread that this will catch on to, that it'll be stable. That might be an issue there that I might have to figure out. I might have to make this a little different later, depending on how the situation goes. But I'm testing, so we'll see. But what I need to do is I actually need to get the diameter of the entire thread on the microphone stand, so that I can make a hole that this will be able to poke through, so that the bolt part of the thread will be able to go through the hole, but the nut here will be retained inside and not fall out, which it doesn't leave us a whole lot of room to do. So we'll see here. I do think I can do it though. So it says 9.2. Let's go back into this main sketch here, and we'll just make a circle right in the center. Let's place the circle, but I need to make another parameter. It would be stand thread width, which was 9.2, and then we will do plus fit tolerance, normal fit tolerance. So that'll be 9.4, which shouldn't be nearly enough for this to be able to fall out or wiggle around. I'm just hoping that it'll work and that my math is somewhat right here. Quote unquote math. I think it's more logic than math, actually. But either way. So we need to put a size on this. Size? Width? Yeah. I have a hard time remembering all these terms that I use. Finish. So now we have that circle, and we can extrude on that circle, and we need to extrude into the retainer. We're going to hide the main body just in case. So this needs to be negative retainer thickness, because then it should be the exact size of the retainer and cut the exact hole that we need into the retainer, and boom. One problem is that if I were to print this retainer, it would probably be printed on this side. So I think the P1P battles it pretty well, especially with the preset slicer setting for PLA, but I think that it does have a slight issue with elephant's footing. But there's also the threads, so the threads might be able to just kind of carve out that plastic around here if I give it extra walls or something like that, and it can kind of carve out the extra space that it needs, and it could make the threads, and if it does, and then eventually those threads will just wear away with enough use. So now I will finally save. So the title, this is PreSonus. I think the microphone is called the M7. I better make sure it is. Okay, cool. It's actually $70 new. That's pretty cool, but that's also for an absolutely new one. I don't know if this one was cheaper. It kind of feels cheaper. The housing is plastic, I think, for the most part. The grate is metal because it's cold enough to be metal. And then this thing is metal, but the actual housing is plastic, and it kind of is flexing sometimes. That worries me a little bit. PreSonus M7 mic stand half. Okay, so I've done that. PreSonus mic stand mount half. This is the first version, so it's not actually going to make me name it, which is surprising. It made it read... Okay, there we go. Which I'm surprisingly not at my document limit. I'm usually always at it. I must have a bunch of things read-only for this issue. Okay, hopefully that should work. Now I can just put a lid on this and then make the rest of the model logically. Let's make a second sketch. We're going to rename this one. Main mount thread sketch. Main mount thread sketch. Okay. Now let's make a new sketch, and we're going to do it on this plane here. We're going to create projection. This is one of your most helpful tools, in my opinion, in this software. We're going to project all of these lines up to here. We'll get the center lines as well, just in case. So now that will bring all of these lines up to our sketch that we're working on now, and they will reference these other ones. So if the other ones change, these ones should change, and all of that sort of good stuff. Now, sometimes you might not want that, but in this case, I don't know. We're just going to keep going with it. So the first thing that we want is to make these construction lines. Now that I think about it, that wasn't what I was going to say, but it's what needs to happen. The next thing that needs to happen, start by making a new thing. This is going to actually be mic mount base thickness, and this needs to be decently thick, I'm pretty sure. So I'm thinking 4 millimeters. 4 millimeters should be enough. And another thing that I'm thinking about is just I'm thinking that I need to print this on its side, which may present an issue for getting the proper dimensions for our holes here, especially the actual circular holes. Which, actually, now that I think about it, solution. We go into this sketch. Instead of using a circle, oh, that might not work though. Okay, new solution. So what I was gonna say is I was gonna make a hexagon, which at that distance, it might be able to print properly because it's not very far. But just in case, I'm gonna do something a little outside the box. Instead of using a circle, I'm gonna try and make a triangle. So polygon, circumference polygon. Let me see, can it do triangles? It can. And then the circle is still the proper size, and then just adds that extra little distance. Interesting. Okay, so we already have a thing for that, don't we? Stand thread width. Ooh. Wait. Oh, I think I did the wrong one. Did I? Oh, I'm looking at the wrong thing. Wasn't this smaller before on the hexagon? Did it just get much bigger because of the triangle? Nevertheless, this should still hold it, I think. Man, I don't know. I'll try it, because I just like the idea of this working. Okay, interesting. But we'll probably only cut out this part. We won't cut out the extra ends. So then we need to go and delete this from our timeline. And then we need to redo it with this other thing. So let's hide this second sketch, hide the main body. Then we extrude this. And then it's the negative thickness. Which one was it? This one, right? Yeah. Nice. I think this should work. I think that would be pretty slick looking too. Even though visual aspect is not what I'm going for, it takes a small, it's part of the deciding factor on a lot of my decisions. All right, so we did that. Let's save that. We made a kind of major revision. Changed retainer hole shape. Did I spell that right? I think I'll get the idea, even if I misspelled it. Now we bring this back into view, get our other sketch, hide the first sketch. Going into here, we actually don't need to. We need to go back out because we need to actually extrude now. We're going to extrude this, and this is why I was thinking that maybe we'll need to put this on its side to be able to print, because of this pretty big overhang, and we don't want that plastic to droop in there because that's going to make issues for our fitment of our hardware here, which I actually have lost now. Oh, it's over here on my phone. Now this is going to be the thickness, this base thickness, just to get a nice base onto here. And we wanted that to join because it is part of this piece. So we're gonna make this the base sketch. Then we are going to make another sketch that's on top of this. And this is gonna be called arms. You can use spaces on these like I did up here, but it's it's partial habit to do it both ways. Okay, so let's get an idea here. So the first thing is we need to figure out the resisting mic mount thickness, which is it's about 7 point. It's kind of hard to tell, honestly. This has to be kind of close. Seems to be about 7. It seems to be 7.7 because this needs to be a very close tolerance so that we don't provide too much strain on the plastic. Which, if we also print this part sideways, that will also help with the strength, I think, of clamping on this part. Pre-existing mount. And then we need I guess I should do it on this, huh? So it's 7.8 on the bolt. Okay, so we have bolt, fastening bolt width which was 7.8. Double check again. So now we have that. Let's apply at least this first number. Rotate this the right orientation. Which way is the triangle? Going the wrong way, unfortunately. Oh well. Okay. Let's just make some lines straight down like this. Then we put the width between them. Degrees? You son of a... They're supposed to be straight. Of course, that didn't work. Okay, now we can do this, because then it should be distance automatically. Yes. And then we need this thickness. And then we will do plus fit tolerance, which will give it 0.1 on each side. Then we have to take this and put it... Let's make this first sketch visible. Oh crap, I forgot to project everything first. So we need to project... Oh, that's not what I want. Project. We need to project these outer lines, first of all. And then we need to project this center line. Now we take this measurement, and then we have to bring it to there. We do the same thing that we just did. Pre-existing thing plus fit tolerance, and then we divide it by 2. That did not work whatsoever. I think it's because we need to put parentheses here. Then that should bring us to the correct order of operations. Now this should be exactly in the center, and this is just the gap that we need. Now we need to decide the thickness that we actually want for our outer parts of our actual arms here. So these are actually 6 millimeters thick, roughly. It kind of tapers off. So 6 millimeters doesn't seem too awful bad. It's pretty conservative for actually functional thickness. So let's go with that. So mic mount arm thickness. Do I already have that? Guess not. 6 millimeters. So now we create more lines, which hopefully won't go off of the geometry, but they might, based on the size. Oh no, they should be good. Just barely. Okay. Finish sketch. Now we have that. Let's hide this first sketch. So now we need to extrude these out to a certain size. What size are they going to be? Well, that depends. So the first thing is that we need to have the actual size of this. Smallest size of this is 18 millimeters. And then we want some tolerance around that. So let's start with pre-existing, I don't remember what the hell I called it. Pre-existing mic mount height is 18 millimeters. And then we want large fit tolerance. So let's just say that as 4 millimeters. Maybe fit tolerance isn't the right way. Let's say large function gap. I don't know if that's going to be a good name, but that's what I'm naming it for now. Large function gap. So then we need to extrude these two things by pre-existing height plus function gap plus function gap. Now that gives it a functional gap, hopefully on the top and bottom, so that hopefully we can place a circle somewhere in a relative center of this. And we're joining that, and then we need to make sketch here. Mic arm fastener. I don't know if that's how you spell oh, that's definitely not how you spell fastener. Isn't there a T in fastener? It is. Right? Unless this is something else. It is. Alright, cool. Mic arm fastener hole. Hold is right as well, but we need a hole. Sketch. I know it's a sketch, but whatever. Create a hole. We already have the size of the hole, which should be... I don't think I called it fastener, though. Tightener? Is it named width? Oh, it's fastening. We'll rename that actually to fastener so that I can hopefully remember. But I wasn't too far off, which is a good sign for my brain. So, we have that now. And so what we need to do is we need to do this. We need to project this line. It's better to project the lines that's not referencing other geometries, just in case the geometries change, because this line should hopefully be forever. Or at least be referenced properly. I don't know. It should change with it all, as long as it doesn't like get completely removed by like completely rounding this off as a like semicircle. So now what needs to happen is we need to make a distance between here. So we need to start with our function gap plus, then let's put in parentheses fastener bolt width divided by 2 is my, okay, it is still there. Now this should give it half of the diameter of this plus the actual length, the functional length, so that this will be a functional part. I mean, it almost worked out to the same size, but it's only like it's only 0.1 bigger, which is interesting. But let's see here. So I don't want these to just be blocks like that. I do want some form, and we're kind of going for like an angular design here. It's kind of how a lot of my designs end up, I think, when I design things from scratch. So I'm just gonna make a line. Actually, okay. Take this center line, sketch it at, I don't know, let's say 20 millimeters and 90 degrees. Boom. This might be wrong. Trying to figure out, I want to make a 45-degree line that will be always perpendicular to this corner. But it needs, oh, jeez. I do something like this. 45. So we create this. Ooh, but that doesn't even seem right. But it has to be, right? Doesn't it? Ooh, and I also referenced a line that doesn't exist, technically. So we need to select this and project it. Selecting it doesn't matter until after. Because we're also going to need that side, so then we'll do that. I'm hoping my thinking is right here, but what I'm going to do is I'm creating this line at 45 degrees, but it's also going to be negative 45 degrees. And then it just doesn't look right, but maybe it'll look better when I have the other side as well, or maybe it just won't matter. Oh, this did not turn out the way I wanted it to. There we go. Now we create that. And these need to be construction lines. And then I need to create another line at 45 degrees down to like there. Once again, it did not turn out the way I wanted it to. Don't know how that happens. This time it turned out fine. So these should already be perpendicular. But just to be safe, I'm going to try and put perpendicular might be the wrong word. Oh, okay, it is. These should be parallel, but just to be sure, I'll try and put this constraint on there, and they both say they're over constrained. Makes sense. Now, I want to take this point, and I think that it needs to be coincident. Constrain the position of 2 points or a point in a line to curve together. I don't know if that's exactly the wording I would use, but I think it should do the function that I want. Apparently, this has already been applied. I wonder if that would be true. Because the one thing that doesn't need to be constrained is the actual length of the line. The length of the line is what I want to change. However, what I do want is for this to be a certain distance away from here. Let's try our functional gap and see how that looks. That looks absolutely atrocious because we need to add our other thing here. Let's exit that and just go into here because it's always a little hard for me to remember. We're going to copy and paste that function. What the frick have you done? There we go. Now we do the same thing for the other side. So now logically, this should be a good shape for actually making this work. One problem is that I did not add fit tolerance to this. And once again, we want it to be kind of tight, but I don't know how it's going to turn out either. Let's do regular fit tolerance. I was thinking about making it normal fit tolerance, but I decided against it. We can also get rid of this line because it's now completely irrelevant. Now I think we can finally put this sketch into action. So first of all, this is a 45-degree angle, so logically, if I printed it on this face, it should be able to print up without needing supports, I think, from my knowledge. Pretty sure. Something that might be an issue is the actual circumference of this hole. It might kind of oval out, which is a common issue because of the drooping in 3D printing, but this kind of does need to stay as a circle. I might be able to do like a diamond shape or something, but I'd rather not. Honestly, it doesn't need it just needs to hold the bolt in place, but it also needs to allow it to turn. We'll go with the circle first and see how it turns out. But the diamond idea is something to try and keep in mind. We're going to finish the sketch, and we're going to extrude this, and it does not matter what the extrusion is. We're going to say 100 millimeters, except for it needs to be the right way, because we just need to cut through the whole thing here. Yeah, all right. Now, the next thing is, I don't think I've ever done a cut like this, and I'm not for sure if it'll let me do a cut like this. split body. Body to split. Well, this is it. Splitting tools. This. Oh, what the fuck? Oh, okay. Okay, so now these get the. Uh-oh. There's associated features. Oh, crap, there is. But these are also different bodies now, so they can. What the hell? Why did that one get the freaking main body? Okay, so this one is now the main body. Okay, well this. So we're gonna rename this one to main body 2. We're not gonna put the parentheses on it because otherwise it's gonna break, I think. So we're gonna name this main body plain, and then this one will get the parentheses. Main body 2, yeah, because this is the one we want to actually be the main body. And I think it's looking pretty good. I mean, I think we're done, at least except for the, other than testing it and printing it. Save, finished, first version. Okay, well, let's print out the main body and see what there is to see. We're gonna save it as an STL. It makes it harder for other things anyway. I guess maybe I should try and save it as a step file. I just wish they made it easier. I have to actually remember how to save it as a step file. I think I click on it and then go to File, Export, and then we export it as a STP. And then we gotta find the right file, which currently I don't think there will be. Let's do a new folder, 7 mic stand mount half, save, export. Supposedly step files have advanced capabilities that someone actually clarified for me. The main reason you'd want to use them is because they always build themselves up based on the steps you've taken to build the object. So if you put it in a CAD file, it should be able to produce all of these steps, and then you can alter it if you so chose to. Now I have to go to the bathroom, so I have to end this recording real quick. Okay, so here we are with the step model imported into Bamboo Slicer. I've never imported. Actually, I did. It was a bit weird. I imported some step models before, but this came up with a prompt menu with edge detection or something like that. Basically just trying to figure out, parameters of how accurate to make it or something like that. This is not right. Which also I realize now that hole probably doesn't matter. Okay, I just realized a few different things. First of all, this model did not export properly, which is really freaking annoying. Is it because can I move this? Nope, it is all one solid thing. But yeah, it came in with some prompts that I've never seen before, so I went with the defaults. And I was gonna start slicing this, but now I realize that it combined my two things for some reason. So that's annoying. I'll be back. Okay, so I just exported this as an STL because that's the easiest way to do it separate. I'll have to just figure out how to export the two parts separately as a step file later. One thing that I was thinking about was possibly trying to make the retainer into another part instead of a body. I've never worked with parts instead of bodies. Usually this is fine. I don't know why these are stuck together now, because I don't want them to be, but I don't know how you select one thing to export, because that's what I did, was I selected this, and then I hit export, and then it didn't work. Anyway, so we have this. We don't need to worry about which way it actually goes now that we don't have the triangle thing. That's the main reason I was worried about it, but the triangle thing, it no longer matters. So we're going to use the Lay on Face tool here in Bamboo Studio. So we laid this on its side. Oh, what did it just do? Get the hell out of here. Alright, so now it's on its side. So printing like this, it may not work because of this overhang, which I could easily support that, honestly. So let's go to first of all, let's go to my copy settings of the normal thing. We'll enable support, and we'll do tree supports because I think they usually work better and with less material used. And let's see how this works. Unfortunately, it did these, but that might actually help. And it's kind of wrapping around, which I don't like. And then it's also combining these two, which is really annoying. Partially not liking that. And then these are just, quite frankly, really close, and they're probably going to conjoin together one way or another. It also didn't worry about supporting these holes, which is going to be really annoying. This did not even turn out nearly correct. Oh boy. Well, I'll tell you what happens if we do it normally? What does it look like? First of all, there's those holes, which they get supported all around. Oh, no. Let me look side here. Oh my god. That is not optimal, I don't think. So, the next thing is to do manual supports. We need to go to the prepare menu, and then there should be a painting tool, right? I don't know how to support painting. There you go. Because we don't want the inside of there. There's a way to just select faces, but I don't fill. There we go. Because we want to fill that. Don't want any of those, but we do want these to be supported. So these should be fine because they're so small. Slice that plate, see what happens. Now, with that density, it should be perfectly good, especially that it adds that. The only problem is I don't know how I'm going to get it out. Might be able to poke through there. I'm not very good with support material, and I do try and avoid it when possible, and Jesus, that is not helpful. I wish I could use normal support and tree support in tandem, because I want tree supports for these, but normal support for that. Damn. On build plate only, which will probably just remove these. Oh, why are they still there? That's not how this works. Is it because they're forced? It's because I painted it, so then it just kind of automatically does it. Well, let's see how tree manual does. Oh my god. It's kind of scary. Why would you do that? Is that actually even going to work? This one is just completely useless. And then it's also making another branch here that's useless. Another one there. That's really freaking annoying. Go back to tree auto. It's part of the slicing process. It's just, wait, what the now it's this, and it put these on there anyway. Okay, well, here's the next solution. Support painting? How do I, okay, there we go. Support blocker. Let's erase all painting actually and just put these on here so that hopefully the wanted supports won't mess with it. Is that blocked? See, now it turned out way better. At least I think so. I don't know if these supports are gonna actually make it. That's a pretty advanced structure. Wow. That is one overhang if I've ever seen one. This is gonna be interesting. It's probably got this weird like parasite looking fucking, yeah, ew, gooey. It looks like fucking fungus. Ew. I don't like it. What's my infill at? So I think my infill needs to be pretty dense, honestly. Strength. Only at 15. Let's do 25. See how that looks. Because I want this thing to be pretty strong to be able to withstand being screwed in and unscrewed a few different times, you know, at least. Hopefully, you know, for the rest of its life, but the rest of the microphone's life at least. Well, I think all I can do is just send this print and see if it'll work. God, that is just scary. These angles are kind of scary the way that they're looking. I don't trust them, but Bamboo usually knows what they're doing, and this is not something I can really fix, I think. There is this angle, threshold angle. Oh, so that doesn't even... So I think that these will just do whatever they want. I don't think I can change that. Maybe in the advanced settings, but I'm not for sure. Alright, I'm gonna print this, see how it works. Okay, so, despite the crazy looking angles, there's the finished model. Let's see if the removal is decent, easy enough. It's got enough area to grip onto that it was, and this support just came right off. Okay, so, like I said, one of the supports had just fallen off upon removal from the bed. The other one here just comes off as well. The tops of the holes are still kind of flat. I don't know if it's really good at face tracking. But yeah, you can see it's kind of flat on top still. So I'm hoping that'll work. And of course the bottom is almost solid, so it's really hard to try and remove. I have to get some side cutters to try and like wedge under here. Or at least like poke in maybe, I don't know. There we go. Never had to deal with support material like this before, so I'm not quite sure what the right method and what the most efficient method of removal would be. God, oh no. It's trying to take me out. There was a piece of plastic that flew towards my eyeball. It's a good thing I wear glasses. Okay, we're slowly making our way, and I'm losing chunks. I don't want to leave those around for my dogs to find. Oh, here we go. We're lifting up on a big piece here. So that was a nice solid chunk right there. It even got some of the grid that was laid underneath. This does not seem right. This seems bigger than it should have been. How the hell did that come out so big? Am I stupid or something? Not exactly. So, we've already said that what the problem is. The problem was that normally when it does measurements, it does diameter, which is the full length of, like, it's like a circle. It's the full length between two opposite ends of a circle. Instead, this time it took the radius, which I believe is the half, if I'm remembering those terms properly. Either way, it did the half instead of the full one when I measured the full length rather than the half. And so this was partially my fault for not noticing, but also partially Fusion 360's fault for doing it that way when majority of the time it does the opposite. It does diameter instead of radius. I don't know why it did radius for that instead, but that's how it chose to be. So for this clip, I continue to get all of that crap out of the all of the supports out, but it doesn't matter because it's too big, so it's not a functional piece, and I go back to the drawing board. Okay, well, the issue is very easy to see and understand. This needs to be divided by 2. And now it should be the proper size. And this seems off. Get rid of this frickin' triangle. How did this frickin' measurement happen? Oh, it's because it was the preset thing. Well, at least the rest of this worked, but how is the rest of the model gonna look? Honestly, not that bad. That might still be usable. So I put the thing in, the bolt and wing nut, to see if it'll work, and it actually does. It works. Damn it! It actually works perfectly, which is some good news, other than the fact that I royally messed up this measurement, because I did not pay attention to that simple fact. This is a lot more like what I was expecting it to look like. And it even looks pretty close to this, just less curvy, more angular. That's the retainer, which right now doesn't even look right. What the hell? Why is it missing the entire hexagon in the center? This isn't right. Cancel that. Which one was that? We'll delete this, because now it's trying to reference something that isn't there anymore. Oh my god. So now I have to try and get that hole back in there. But this will probably print properly, because it has to print basically on this base anyway, if I need it. I was gonna say let's try it, except for this. So, also I did have a little bit of issue putting the bolt in this hole, but I just put a little force on it and threaded it into the hole, and it's getting the job done, so at least there's that. Now this, though, don't want to have the same issue happen. I want to have there be enough room that this hole does not touch the threads, but it keeps this damn nut side. Where the hell did the nut go? I swear to God, dude. I was having a good... Oh, there it is. I was having a good day, and then I had some shit happen, and the day got kind of ruined. I'm kind of in a bad mood, and stressed in general. So this hole is making me more upset than it should, and I'm trying to think about how to properly do it. I mean, I have the whole diameter set, right? Stand thread width, and then I already have fit tolerance on there. I mean, I guess let's just put it on the sketch and try again. And that is the whole way, so that is how it should look. I'm debating whether or not I want to double tolerance it. I think that would be best. So let's put double fit tolerance on this. So now I'll have 0.4 fit tolerance, and it hopefully should work. I need to extrude the hole though. So negative something thickness. It was retainer, wasn't it? Retainer thickness. Okay. Cut that. Now we have the hole. I have to remember which part of is actually the main body. Oh, right. It's the one that was named main body. What are these? Oh, okay. Well, we can't delete them because they're referenced. I'm thinking that we should just try it. Try this print and see how it goes. And there is less worry about this because it is much smaller, like I had originally anticipated, which is why I got kind of confused before. Because now this shouldn't sag, but it might. There is still some stuff in here that could make the nut not properly fit in there. I'm debating whether or not I should just try and make this hole the same size, because then I might be able to like pound it in. I don't know. I'm thinking I'm just gonna go with this and see how it goes. Also, the little holes turned out well, so that's cool. These little slots. Save, I made the hole too big. Now it's not. That's a good save title. That says the entire situation. Save as mesh. God, even that thing looked freaking weird. It looked so wide, and I was like, that just doesn't even seem right. Of course, now I look even more foolish than I did before. Slice the plate. Let's see how this looks. Jesus Christ. Got this damn frickin' center one, which is going to be a pain to get out if it doesn't just break off right away. It probably will, but it's not guaranteed. Now, I need to go into the prepare menu and do some painting. Make these do not disturb areas. Okay, now it's not doing that. Those. Alright, well, let's print this and see what it looks like. Okay, so there is the second printed model. I was about to go to bed and then I saw this finished, so I decided I was going to come in and get this. So the bed is still hot, so this is a little more difficult to remove, but I got it. And all of the supports have just kind of flung off, so that's neat, except for, of course, the middle one. Okay, well, this is part of the issue. Oh, there it goes. Never mind. Okay, so now I have to try and remove the supports from the bottom here, which can be a bit of an ordeal. I don't know how much of the other clip you saw, but it was not fun the first time. There's less this time, but it's also in a more confined area, so I'm not sure how much easier or more difficult it will be. And it's also the tree support, so it's more stable in here in terms of removal, so it's harder to remove. Well, I've opened up the lid kind of. The surface has been disrupted, but there are the little veins, the trees, the stems, all of that. They're still in here, and I am having trouble getting it out. I'm gonna try and keep the plastic from falling on the floor so my dogs don't find it, and so that hopefully it can be recycled into more plastic one day. Hopefully filament recycling will become more of a mainstream thing, and that was a lot easier at the end there. So yeah, you can see the stems, the veins, whatever you want to call them here. A little freaky looking when you depending on how you look at it, but yeah, this is more of what I was expecting, is what I'm trying to say. The other one is freaking huge compared to this. And now I gotta go get the hardware and see if this works, because I didn't think about bringing it in. Okay, you should be able to hear me more easily now that the fans have stopped on the printer. I have brought all of the pieces. I removed the bolt and wing nut from the other one, because obviously I need it on this one. It's assumed in? No. Okay. Now this is just barely not fitting in the nut. So I might need to, I just pushed it in. So now I got it in the socket, but it's not all the way in. I might need to like rubber mallet it in somehow, but I'm not for sure. Maybe I can I don't want to clamp. The problem is that it's a 3D printed object, and it's not super strong. Oh, I got it in. I pushed it in more with my brute strength. Okay, well, it's not 100% in, but it's pretty good. And I think this will work. Interesting. Okay, well, let's test this out. So this worked last time on the other model, so I don't see why it shouldn't work this time. The model fits, the original model fits in the slot. The bolt is still having difficulty fitting through the hole, but I'm just going to thread it in, and then I'm just going to kind of force it to work because it did last time, so I don't see why it shouldn't this time. And then once I get it through, about that far, Then I noticed that I could just put the wing nut on, and then the wing nut will start to pull it inwards. If you can see this, it's hard to keep it still enough to be able to see. Slowly shrinking inward. And then this creates clamping force, where it will now sit in place. And I can change the place, and it'll sit in place. So this is a pretty extreme success, other than my kind of failure before, where I messed up the thing. I guess before I call it a success, I have to put it on a microphone stand. Alright, here's one. In my music room, but I left my actual microphone stand that I would planned on using in the other room, with in my bedroom where I usually do my computer work. So this has a weird mount that is meant for cameras, that is meant to go on microphone mounts, because it's harder to find good camera stands than it is microphone mounts. And this is not a good microphone mount, honestly, but it gets the job done. And this freaking adapter is really on there. And I'm looking for something to help me grip it. The shirt's already messed up. Let's see if I can get it off of these threads are just, and there's no slotting on it, so I can't unscrew it with a quarter. Oh, here we go. I managed to loosen the bolt or whatever, this little thing behind it. I managed to untighten it with that, and now I can finally have a grip on the attachment here. Because unfortunately, like I said, I did want to be able to fit over these big things to be able to make it, I think, a little more universal, because that's what a lot of mounts seem to use. Oh crap. What I didn't think about was the angle at which this would be, but that's what this spinny thing is meant to be for. Okay, so we turn it like that, and we spin this, and now it's tightly on there. What can I say? Oh, except the nut seems to have, I think, fallen out of it. It's slipped out of place while spinning it. So I might need my retainer. I might need the retainer on there. But that would also mean that I need to get it properly in place. So I thumbed it back in place so that it's flat again. It was sticking out. Let's see. I don't know why it fell out. Okay. So it kind of came out again. I don't know why it does that, but it can't go back in. This stand must be longer. The threading must be longer than the other stand. That's what I'm thinking. So I probably need to make another one of these with a bit of a longer base so that there is more room. I was originally trying to plan for it, but then since it came out flush on when I screwed on the nut here, when it came out flush, I decided that I wasn't going to worry about it. Should have worried about it. But I also probably wouldn't have done enough room anyway. Dang it. Well, I mean, it still works for now, but I mean, it wouldn't be a complete video if I didn't finish the project properly. It just kind of annoys me to have to print another one, you know? I guess it also would have helped if I had the retainer, but that's, I don't know. I don't want that extra distance on there. It's hard, I don't know. I don't know how to keep I guess I don't, because I don't want to glue it either. Anyway, I will be back tomorrow, hopefully, working on this, and hopefully I'll finish it. I'll hopefully finish this model. Okay, so we have experienced the amazing thing of 3D printing that allows anyone to create an object and then fail at it. But then you can somewhat easily create another one, hopefully. So, yeah, it's a new day. The issue was that this needs more depth. Now, I was thinking about this and I was like, how am I gonna find the right depth to actually do this? Well, I have my example thing here. I happen to pick this one, but I have a lot of these regular microphone mounts. However, this one has this logo on it, which you probably can't see from here, and I can't tell because my preview only shows my screen rather than my webcam. But this is the Audio-Technica logo. Honestly, I don't know why I have this mount. I don't remember where I got it. I don't know if it came with my AT2020, but it doesn't fit on this mount. And this is for your average mic that you've seen, probably like this one. This one has this type of mount. However, what this does mean is that this should be an industry standard, and it should be able to tell me the optimal depth that should work with just about any microphone stand, especially any of the ones that I have, because this thing goes really deep. I don't know if you're going to be able to see that. I don't know if I'm going to take a picture of it. Probably not, but it goes pretty deep. So I don't own a microphone stand that has a thread of that many count. Because, well, for example, this is how deep usually they go, but this is only like that much of it when the threads go down to basically like here or something like that. It goes pretty deep, very, very deep. Anyway, to try and make it universal, I'm gonna try and make some space for that entire length. Now, there's not a good way to measure this except for one way I saw oddly on a Linus Tech Tip, I think, and you use this little pokey bit of your caliper to measure the depth of things, which honestly I had never even considered, which is wild. So this depth is about 20.8 millimeters. Okay, interesting. Now we have to take this and put it into a parameter. So let's say standard stand thread mount depth, and it was 20.8, right? Yeah, 20.8. So we add that, and then what? That's a good question. So there's a proper place that I need to do this, and I'm not quite sure where. I'm hoping that the sketches, since I placed them on some of these surfaces, will move upward properly when I move the geometry, because this is going to get a lot taller. So I'm hoping that this will all properly move up, but I have no clue if it will or not. The only way to find out is just to do it. But I have to figure out where the proper extrusion is. This? Yes, it is. Okay, so we have this base thickness. Because this base doesn't have to be super thick now. Interesting. I'm thinking. Because the depth of this is starting right at the bottom here. So we can take the measurement from here and just extend that out to cut the hole properly, hopefully. But I haven't even gotten to test if that hole is big enough yet, actually, because I never used the retainer. So here's what I'm thinking. I'm just going to use this function, actually. So we have to find that function. It was called base, mic mount base thickness. Yeah. So let's change this up. I'm going to put 2 millimeters plus, and in parentheses, standard, dang it, type right. Then we're going to divide that by 4, and then multiply it by 3. Now, what I'm trying to do here is I'm trying to get 3/4 of the length needed, because I'm hoping that this will make up that extra third of the length, at least mostly. 17.60. I need to do a measurement. Can I select this line to that line? The distance is 25.9 millimeters. Okay, so that is 5 millimeters over, which, let me see how much 5 millimeters is. It's not that much. I can deal with that. Did I explain what I was trying to do here? Alright, so now we have that. The next issue is this hole. I'm debating. Well, here's what I'm going to do for now. I'm going to go back into this main sketch, and I'm going to make another hole. I'm going to make another circle. And this one is going to be something width, wasn't it? Stand thread width, okay. And then we're going to do plus, and then in parentheses, fit tolerance. Then we're going to multiply that by 4. I'm hoping that that will be enough for proper fitment, and that, so that it shouldn't. You know, wait, why did it not put the string in there? Doesn't seem right. What was it called? Stand thread width, and then we will do +1. How does that look? Is that just literally the same thing? No, it's a little bit bigger, but we'll give it a millimeter of tolerance to just try and hopefully make sure it doesn't impede the threads going in, so that hopefully it can just screw on smoothly with the normal screwing action. So the final step, from what I know, is to just simply extrude this, and it should be going in the right direction now, and it should make a cut. The next thing is the standard. There we go. So then it'll cut all the way up to there, and it'll have 5 millimeters of extra space to properly make. Oh wait, those supports are gonna suck. Ooh, I did not think about that. I could experiment with printing it in a different dimension, or on a different plane, like printing it on this face, because then logically nothing should need supports except this whole might droop, and then I guess this might droop as well, but this would be easily supported, and so would these other holes, but fortunately this one, not so much. Would have to support inside. Well, we have to make this cut either way, because it's part of the design that we want. And normally I would add like a chamfer or a rounding in there, but we don't want the nut to fall in, and it logically should have more than enough room to just go directly in the center of the hole. So we shouldn't need anything like that. Now we will save. Added more stand thread. Alright, so now we can export this once again, and we will get into the slicer and see what we can do. Okay, here's the old model, deleted. Put this new one in, color, okay. Let's see how it looks with the selected settings. It's going to put these in the hole, which is going to be annoying. That is really annoying, the way that turned out. That's even worse than having it be separated. Okay, but let's see how it turned out in here. Ooh, actually, it branched off of one tree. So logically, that should be fairly easy. However, I do need to remove, it's going to change up the pattern when I add the blockers for these little holes, because there's no way I'm getting those supports out. So we need those to be blocked. Okay, cool. It still did that thing, so that hopefully that means that the inner one didn't get changed too awful much either. Okay, cool. So it actually didn't change much of anything. It was changing before, but now it's not. So yeah, we got these coming up, and then it spreads out again. I think that this should be pretty doable, actually. It's not going to turn out as horrendous as I thought it was going to. I'm feeling pretty confident in this one. I think this one's going to be our magnum opus. Might not be the right term. Alright, well, let's send the print and see how it works. Okay, so we're here with the final printed model all assembled. It has our hardware in it. This is as far as I could get it in. It's not completely flush, but it sticks out a little bit, but that's okay. So now we are looking at the microphone stand. That was a little too long for the thing here, but we have our extended storage area of this little nubby shaft. So we just have to attach this to it. I just have to make sure I'm not going to cross thread it. Okay, let's try this again. Much easier. And I'm able to screw it on fully without having the nut insert fall out, get pushed out by the extra area. So we can just put this on here, if I can get it set in properly. This design is still not ideal. At least the overall design of this microphone mount is not ideal. My design is about as good as it gets for this, unfortunately. Well, fortunately, I don't know. I designed it, I think, fairly well for what it is. Tighten this, then we can loosen this, make it go straight, and oh, that's not good. Oh! So One thing that I did forget to design in was a stopper for this. I wanted to have this inset into the plastic so that it wouldn't rotate once you get to maximum tightness, because then you can't tighten it anymore. But it still does get to a proper tightness where this will stand on its own like it needs to. So this design is basically 100% complete and finished, as far as I can tell and concerned with. The only improvement that I can make is, again, maybe adding an inset for this so that it will stop the turning, and then buying a different bolt, because this bolt just sticks out just a little bit too far. But that's only a minor cosmetic issue. I mean, it can take up a little bit of space if you're working in like extremely confined area. But yeah, this is finished as far as I can tell. So, if you found this video informational or entertaining, please consider leaving a like. This channel is normally a music and 3D printing channel. Normally we talk about guitar gear and review it, and then sometimes we talk about drum and bass guitar gear and talk about subjects in that. And then we also talk about 3D printers, review them sometimes when I get the chance. And then I also talk about issues around them, trying to solve them or just bring them to light so that either the community or the actual companies can fix them, or at least we can find solutions for them. There are affiliate links in the description that will lead you to some good stuff that I personally use. Using those links will help support me. Even if you don't buy exactly what is on the link, you can, once you click on the link, if you use that same tab, you can go and buy whatever, and I get a little bit of that still. And I don't currently make any income, so that would be greatly appreciated. Using those links and liking the video, all that sort of stuff will help make me be able to continue making videos like these, showing how to design these objects, fixing everyday problems with 3D printing, and just being able to create things basically out of thin air, like, you know, the quote-unquote magic of 3D printing. So, thank you for watching this. That's all I have to say for now, so I'm gonna say bye-bye.